Okay, section 10.3. This is our last section of the semester. And we're still going to be dealing with these radicals. The first, let's see, 1, 2, 3, 4 problems are going to have fractions under the radical, which means let's just separate them out into two separate problems and work them like two separate problems, right? If you have a fraction underneath your square root, you can put them as two separate things. Like on number 1, you have the square root of 100 over 121. Well, that's the same thing. Let's just rewrite that. That's the same thing as saying the square root of 100 over the square root of 121, and then just treat them as separate. What is the square root of 100? What times itself is 100? 10 times 10. So the square root of 100 is just 10. And then do the same thing in the bottom. What is the square root of 121? What times itself is 121? 11. So 10 over 11. So again, on these first 4 problems, just break them apart into two separate problems and work them from there. Same thing on number 2. You've got the square root of 7/16. Well, I'm just going to separate that again. Okay, I know what the bottom is. The square root of 16 is 4, right? I can figure that out on my own. The number times itself, that is 16, is 4. But what about this top? What times itself is 7? There's not a whole number. Times itself, that is 7. So for right now, what we're going to do is just bring that over, right? It's not like the 16. You can't just say, oh, 4 times 4 is 16. There's not a number where you can go, that number times itself is 7. So we're just, for right now, just going to keep that underneath its radical because we can't simplify it. So you're just bringing the top over since it can't simplify, and then taking the square root of the bottom. Let's do it again. On number 3, separate them. Square root of x over the square root of 9. Let's see again. I can do the bottom. The square root of 9 is 3. Look at the top. Remember what we talked about at the very end of 10.2. How do you take the square root of an x with an exponent? I don't see the exponent, which means it's a 1. You would divide it by 2. That's our shortcut, is we want to be able to divide this exponent by 2. Well, 1 is not big enough to divide by 2. It's not even 2 yet. Okay, so I'm just going to leave this just like it is. I can't simplify the square root of x. I can't divide its exponent evenly by 2. Okay? Number 4. Square root of w to the 10th over 81. I'm going to break it apart. Let's see again. I'm going to do the bottom first. It doesn't matter. It's like it's two separate problems anyway now, right? What times itself is 81? 9. Now, this top is different than the last one. It's not just the square root of x. It's the square root of x to the 10th. So let's see. Can I divide that exponent by 2 evenly? I can. Which is exactly what the shortcut says to do when you're taking the square root, is you want to divide your exponent by 2. So the square root of w to the 10th is w to the 5th. Okay, square root of 54. It says express the radical in simplified form. It doesn't say simple. So what we want to do here is I say to myself, 54 doesn't seem like one of those perfect squares that I'm used to, like 25 and 36 and 49 and 64 and 100. We know several different perfect squares. 54 doesn't seem to be one of them in my memory. Let's just check it. So if I wanted to take the square root, remember here's my square root button. It's that blue function, which means I need to hit the second button first. Square root, type in 54. Look, so that tells me it's not a whole number. It's in between 7 and 8, okay? But it's not a whole number. So this is what I'm going to do. I want to break this number apart into 2 square roots. That when I multiply these 2 numbers together, they've got to equal 54. So the first thing I need to do is come up with all the ways I can multiply to equal 54. So let's see, 54 times 1, it's even, which means I'll be able to do 2, and let's see, 27, let's see, 3 and 18, not 4, not 5, but 6 times 9, not 7, not 8. So let's see, what if I didn't want to do that on my own? Remember back in the factoring where you can make that table for yourself in your y equals. So if you go to y equals, clear it out if you have something in there. Type in whatever this number is under your radical. So 54, and then hit divided by x. Here's your x button. Now, I want it to make this table, hey Billy, I want it to make this table on its own. So this right here, I'm going to hit second table. So there's all my ways to multiply to get 54. I don't care about anything that has a decimal. So do you see it has all the numbers that I've come up with? There's my 6 times 9. There's my 3 times 18. There's my 2 times 27. There's my 1 times 54. It has all of this for you. So that's the first step, is to come up with all the ways to multiply to 54. The second step is the number that you put in this first square root has to be a perfect square. It does have to be one of those numbers that you can take the square root of. So when I'm looking at these numbers, 1 is a perfect square, but we don't ever count it in this. I look at all these numbers right here and say, are any of those numbers a number that I can take the square root of, or a number that is a perfect square? Can you take the square root of 27 and get a whole number? No. What about 2? No. Going through this. Look at this number though. Is it 9 one of those perfect squares that we talked about? There is 9 is a perfect square, right? What is the square root of 9? It's 3, right? So this number is a perfect square, which means it's going to come here in your first radical. So the 9 comes here. Now remember, these two things have to multiply to 54 or else you've changed the problem. So 9 times what is 54? 9 times 6. So this radical over here is just kind of like what's left over after you put your perfect square in the first one. It's kind of like just your trash. What's left over? So once I've split it into 2 square roots, this first one being a perfect square, I made this be a perfect square so that now I can take the square root of it. The square root of 9 is plain 3. Your trash radical, the one that you just put all your leftover junk in, just comes down like it is. Square root of 6. Okay? Okay, moving on to number 6 is the same kind of problem. We do have a negative, but it's outside of the radical. So you'll notice you have negative and then a square root of 20. So then when your negative is on the outside of the radical, it has absolutely no effect on what's going on inside of here. So it's just like it's going to just come down. Now, 20 is not a perfect square, right? If you type in the square root of 20 on your calculator, it's going to give you a long decimal because there's not a whole number times itself that's 20. That's what tells you you've got to break it up into 2. Now, remember this first one always has to be your perfect square because that's the one you're going to take the square root of in a minute. So let's think about all the ways to multiply to get 20. The first one's 20 times 1, but remember, we're not even talking about 20 times 1 because 1 doesn't help us. We still have 20. You haven't simplified anything. Let's see, 10 times 2 and 5 times 4, okay? So let's see, we don't count the first pair because breaking it up to 20 or 1 and 20, you still have a 20. You haven't done anything. You're just kind of bringing it down, okay? So I'm looking at these 4 numbers, and I'm trying to find the one that I can take the square root of. A lot of people look at it and go 10, but if you try to type in the square root of 10 in your calculator, it's going to give you a decimal, right? It's not a perfect square. There's not a whole number times itself that gives you 10. But what about this number?
Yeah.
Okay, so you've got the square root of 4. That is a perfect square, which means it goes in your first square root, right? That's where your perfect square goes. So 4 here, 4 times blank is 20. So that's your 5. Now, this negative again, it's just going to come down. The square root of 4, since I made it be a perfect square, I know I can take the square root of that. What is the square root of 4? 2. It always happens with your trash radical, the one that you just put whatever was left over in. It just comes down exactly like it is. Okay? All right, number 7 on the actual handout says negative square root of 54, but since 54 was the one on the problem right before this, I'm just going to make it another number just to give us some different practice. I'll just change it a little bit. I'll do negative square root of 50. So again, the negative's on the outside, so it's not affecting what's going on in here. I'm just going to bring it down. Then I'm going to break apart the 50. Now remember, the 2 numbers have to multiply to 50. So let's come up with those first. 50 and 1 doesn't count. That doesn't help me. 25 and 2, 10 and 5. Is there a number in this group that you can take the square root of evenly? That one right there, right? What times itself is 25? 5. So I can take the square root of 25. And remember, where does your perfect square go? Always in your first radical. So here's where I'll put the 25. 25 times 2 is 50. Bring down this negative. Square root of 25 is plain 5. Drop down your trash radical, the square root of 2. Okay? Let's look at number 8. And there's only 11 in this section. Square root of 35. And it says to simplify the radical. So let's see, 35 is not a perfect square. Let's see, 35 times 1, but I can't ever use the number times 1. There's only one other way to multiply to get 35, 7 times 5. So, if I'm going to break this apart into 2 numbers that multiply to equal 35, and this one has to be a perfect square. and this doesn't count, I'm looking at those two numbers only. Are either one of those a perfect square? Am I going to be able to put one of those numbers in this first radical and then take the square root of it on the next step? Not going to be able to, right? Neither 7 nor 5 can be a perfect square, which means this cannot, that's when you're going to check the B option. Cannot be simplified. It already is as simple as it can be. Okay? All right. Number 9. You got the square root of 12t squared. So again, 12 is not a perfect square, so I can't just take the square root of it like it's written right there. So I'm going to break it up. Let's see, how do you multiply to get 12? 12 times 1, 6 times 2, 4 times 3. Are any of those numbers perfect squares that I can put in this first one, and then on step 2, take the square root of that number? A number right there, right? I can take the square root of 4. So that's the one I want to put in my square root, which means my trash needs to be 3, right? Because 4 times 3 is still 12. So something new in this problem that hasn't been in the previous ones is I do have a t squared, which means I want to still put as much as I can over here to have as little trash as possible. What is the shortcut that we talked about in 10.2 when you're talking about exponents? You want to be able to divide your exponent by 2 when you're talking about taking the square root of it. Can you divide this exponent by 2? Yeah, it's a 2. You can divide it by 2. So that means it is a perfect square, which means it comes in my perfect square radical, which is always the first one. So put the whole t squared in here. So I say this is a perfect square. That's why I put it all in here. If I want to simplify that, I should be able to now. The square root of 4 is 2. The square root of t squared is t, right? If I divide that exponent by 2, I get 1. T to the first power is just t. In other words, when you're taking the square root of an exponent, you're saying what times itself is t squared. T, right? T times t is what gives me t squared. So the square root of 4t squared is 2t. Your trash just always comes down like it's written. All right, 2 more. Okay, same thing. So 121 is actually a perfect square. So at first I'm thinking, I don't even need to break this up, right? Because what times itself is 121? 11. So that part is a perfect square. And I don't need to break it up unless there's things in my radical that are not perfect squares. But when I get to these exponents, remember the shortcut is you want to be able to divide your exponent by 2. Well, I can't divide those exponents evenly by 2. That is what tells me I'm going to need a trash radical that I can put anything that's non-perfect square in. It's just that I can put all of 121 in my perfect square radical because it is a perfect square. Now, remember, the shortcut is you're going to want to divide this exponent by 2, which means it just needs to be even, right? All even numbers divide evenly by 2. So if it's odd, won't the number right below an odd number automatically be an even number? It will. So I need to put x squared, the number right below it, to make it even. in my perfect square, which means what's left over? An x, right? X squared times x gives me that x to the third. So I'm just putting, again, still putting my leftovers in my trash. What about y to the ninth? Again, it's odd, which means I just need to go to the number right below it to make it even and put the leftover y in the trash. So remember, what is this first one? It is always, because this is what you make it, a perfect square, so that in step 2, you can take the square root of this. So let's see, the square root of 121 is 11. What's the shortcut? Why did you make these even and divisible by 2? Because that's what you do with square roots of exponents, is you divide them by 2. So that one, if I divide by 2, will just give me x. This one, if you divide y to the 8th by 2, you get y to the 4th. Your trash just drops down. All right, last one, and I threw this one in there to see if you were paying attention. I've got the square root of 9x to the 6. Is 9 a perfect square? Can you take the square root of 9 and get a whole number answer? You can.
Yeah.
Right, you can, right? Is that exponent even? Can you divide this exponent by 2? You can divide 6 evenly by 2. This whole thing is a perfect square. If it's a perfect square, there's absolutely no reason to break it apart. It's like you would have had, if you broke this apart, you would have put it all in the front one because it's all a perfect square. I can just go ahead and just straight up take the square root of this. The square root of 9 is 3. The square root of x to the 6th, which means just divide your exponent by 2 to get x to the 3rd, which is the end of 10.3 and the end of all new information for the semester.